Hello everyone. I am so excited to announce that we are going to start another video series and this time about software defined networking. However, before going to start the course, it is important to revise some of the basic concepts of networking. So in lecture number 1, we will be talking about some elements of the modern day networks. Here is a brief roadmap for this presentation. I will start this presentation with a basic ecosystem for networks and then some examples of network architectures like Ethernet, Wi-Fi and cellular networks starting from 0G and moving towards 6G. After that, cloud computing and at the end, Internet of Things. But I will not talk about Internet of Things. You have to explore this concept by yourself. The objective for today's lecture is that it will allow you to understand the modern networking ecosystem, like the components of a networking ecosystem, for example, end users, network providers, application providers, and service providers. You will also be able to learn about the Ethernet, Wi-Fi, their standards, data rate, and their applications. And finally, we will shed some light on cellular networks and cloud network as well. Let us start with the networking ecosystem. Okay, one thing I would like to share is that I expect that all my students are well aware of some basic network concepts, which means that you have studied the networking fundamental course at your bachelor level or maybe at the MS level. So we will not go into the basic details of networks, right? I suppose that you have already taken basic courses in networks. Okay, so keeping that in mind, let us see our networking ecosystem. Ecosystem exists in order to provide services to the end user. The term end user, or you can say simply a user, it is a general term which mean or which refers to user who are working within an enterprise or in a public setup or even at homes. The platform could be a fixed platform like your desktop computer, like your workstation, or it could be a portable computer like your laptop, like your PDAs, or even your mobile smartphones, for example, tablet and your smartphone, etc. It could be anything. But the user is like in different places, and the user is like using different platforms to access services on the network. Sometime the users could be at home, sometime he or she could be at a public setting or maybe working with an organization. All right, so let us see graphically how a networking ecosystem is and what are the different entities or components. Here you can see that our end users, or you can say simply our users, they connect to the network based services. Here we have different services and the users are connected or accessing those services through a wide range of networking facilities, network access facilities, right? So a wide range or a wide variety of network access facilities are available. It could be like your DSL, digital subscribe line, your cable modem that you are using at your homes, Wi-Fi networks, or even WiMAX, or maybe if you are using cell phones. So cellular modems or 3G, 4G, 5G are there. So access network could be there are different options available for accessing the services by using network access facilities, and some of them I just mentioned. And these network access facility actually enable the user to connect to the internet. You see, we have internet here and we have end users here. we want to access the services at the top layer. For that, we need internet access. To access the internet, we have different network access facilities available to us. So user wants to use the network facility to access applications and contents. Here in this figure, actually three broad categories of interest have been shown. The user in which the user is interested, like the application provider, the application service provider, and the content provider. Let us talk about the application provider. The application provider actually provide applications, or you can say apps, and those applications run on the user's platform, which is typically a mobile platform in most of the cases. And more recently, the concept of an app store has become available for fixed and portable platform as well, from where you can download different applications like that. And then we have the application service provider. The service provider act as a server, or you can say a host of application software that is executed on the provider platforms. Traditional examples of such software could be your web servers, your email servers, your security servers, your database servers, and so on. And mostly the prominent example of service provider, application service provider, is through cloud computing, about which we are going to talk at the end of this lecture. We also have the content provider. Content provider serves the data to be consumed on the user device. For example, it could be an email, a music, a video, a streaming, things like that. And examples of the content providers are, for example, the music records, labels, and movie studios, etc. So the contents, even it could be your text-based contents, image-based contents, and things like that. So a very general depiction is shown here in this figure. Two modern networking elements which are not present in this figure, they are data center and IoT, or you can say edge computing or fog computing, because after cloud computing we also have other platforms available, right? We have data centers, we have IoT setups, we have fog computing, we have edge computing, but those are not mentioned here. Okay, so this is at an abstract level how the networking ecosystem is, how the user access services which are provided by different application providers through the internet by using network access facilities. Now let us see some more examples of network architecture. Basically, we will be focusing on two different types of architecture. The first one is going to be a global network architecture, while the second one is going to be a low-level network hierarchy. First, let us see a global network architecture. Here in this figure, you will see different type of entities. You will see servers, PCs, different types of routers, switches, internet, IP backbone, cellular networks, Wi-Fi networks, and so on. You can see the description of some of the entities here at these legends. Well, the core of this global network architecture is the IP backbone. This is the core part of this architecture, and it actually represents a portion of the internet, or you can say an enterprise IP network. And inside this backbone network, we have high performance routers, and these routers are known as core routers. And we also have some high performance link which are known as optical links. And some of these routers are known as edge routers. Edge routers. As the name indicates, these are the routers which are installed at the edge of the network. They are also known as aggregation routers. Beside from the core part, we also have another sub component which you can see at the upper part of this figure, and it actually represents a portion of what might be a large enterprise network. Here we can see two different sections of a network, section 1 and section 2, and these are connected via a private high speed wide area network. You can say you have a company and it has two different campuses or at two different locations, and they are interconnected with one another by using a wide area network technology like MPLS. We will not go into the details of MPLS, but they are connected by some form or some way. And for this interconnection, we require different switches, optical links, IP addresses, protocols, and routers and things like that. At the lower level of this global network architecture, we have some more setups. The left side here, what you can see is a small to medium sized business setup. This is like an organization and their network setup. They are connected with the internet with the help of this router. And inside this organization, we have different PCs, we have internal servers, and we also have some switches. And this setup as a whole represent a small to medium size organization. You can say this is a layout for a small or medium sized business, and it actually relies on Ethernet, which we are going to discuss in a moment, or you can say cable based local area network. And the connection to the internet in this case is through a cable or DSL connection or something like that. Maybe it could be another dedicated high speed link. On the other side, what you see here in the middle is a home setup. Individual residential user, how he or she is connected to the ISP, to the internet. Okay, and we also have on the right side of this lower portion cellular networks. You can also access the internet with the help of the 3G, 4G, 5G connections, your smartphones. Public cellular network is another way or network access mechanism by using which you can connect yourself to the internet. So this is actually a global network architecture. On the other side, let us see a more specific, a typical network setup. There is a common setup in many enterprises, and it is actually a three-tier hierarchy which represent access networks, distributed networks, and the core networks. We studied core network here, but now let us see it again. In this setup, closest to the end user is the access network. And typically, as you know, access network is a local area network or a campus-wide network consisting of LAN switches, routers, and your PCs. And also on the second level, we have a distributed network. One or more distributed networks are the components of a network which are connected with the help of this distributed setup. The distributed network actually connects access networks. For example, you have two access networks here. They are interconnected with one another with the help of this distributed network. They actually connect these access network with each other, and also they connect this access network to the core network at the upper layer. Okay, and for that we actually required some sort of routers. You remember from the legends, we actually required some core routers and also some edge routers. So this is an example of edge router because it is at the edge of the network. Again, we have some edge routers here. Okay, aggregation purposes. Distributed network will also allow you to access the core network. And this cooperation between the routers, sometimes it is referred as peering. Okay. A distributed network may also directly connect servers that are used to multiple access networks, such as database servers and network management servers and things like that. The core network, it is also referred as a backbone network, as we just saw. It actually connects geographically distributed networks as well as providing access to other networks that are not part of the enterprise network. If you want to access services outside your organization, then you have to refer to this core network. Okay, which is actually acting as a backbone network. Typically, the core network will use very high performance routers, high capacity transmission lines, multiple interconnected routers for increased redundancy and things like that. This was a typical network architecture which is based on three-layered model. The layers are access, distributed, and core network. Let us talk about Ethernet. I'm sure most of you, majority of you, will be familiar with the concept of Ethernet. Because there is something that we use inside our local area network. You can say it is the most popular physical layer local area network technology which is used in today's world. It provides you the framework for data transmission, for data sharing. And we have lots of standard available for Ethernet depending on the speed. Like we have a data rate of up to 10 megabytes per second. Other lanes, they have faster Ethernet, even gigabit Ethernet connections like 10 gigabit Ethernet, and sometime ATM and local talk and FDDI. So different types of Ethernets are available there. It is a popular technology for not only for local area network, but you can also use them for metropolitan and wide area network as well. And the standard was defined by IEEE. And the name of the standard that we use for representation of the Ethernet is known as 802.3. Okay, and this is actually the commercially available standard for the local area network. So we have different Ethernets available, like fast Ethernet, and with fast Ethernet you have to place a U here after the 3, which represent fast Ethernet, and they have speed limits from 10 megabit per second to 100 megabit per second with only minimal changes to the existing cable structure. And there are also other type of fast Ethernet available, like 100 base TX or 100 base FX or 100 base T4 lines. Even they are also available. Okay, but we will not go into the details of the Ethernet standard, because we also have some other type of Ethernet like gigabit internet, and we have like 10 gigabit Ethernet. We also have the ATM, we also have the power over Ethernet and things like that. But we will be focusing more on the applications of the Ethernet, where we actually use the local area network or wide area network or metropolitan area network that rely on the cables. The first application of the Ethernet is in home. Because it is the predominant wide network technologies, it is mostly used in homes to create a local network of computers with access to the internet via broadband modem or router. It provides you high speed and low cost Wi-Fi connections on computers, tablets, smartphones, and other devices. So home users rely on Ethernet, but with the emerging technologies like Wi-Fi, like 3G, 4G, 5G, and now 6G, people do not rely too much on the Ethernet inside homes. Although Wi-Fi wireless connection can never be a replacement for the wired networks, but still people at home prefer to use Wi-Fi or other forms of wireless connection due to ease and due to mobility and due to portability issues, right? But still you can use Ethernet at homes to connect to the internet. However, in offices, in organization, we still rely a lot on the Ethernet. It is still the dominant network technology for wide local area networks or wide lanes in office environments. Early on, there were some competitors for providing wide-based services to the offices like IBM token rings and FDDI. But the simplicity, performance, and wide availability of Ethernet hardware eventually made the Ethernet the winner technology. And still, it is the dominant technology to be used in offices. So it exists in offices. It means that it doesn't mean that all setup is going to be dependent on the Ethernet. At offices, sometimes we use Ethernet. For some areas, we use Ethernet, but for other areas, we also require Wi-Fi. Or you can say these two technologies go hand in hand. You need Wi-Fi access in your offices as well as Ethernet technology at your offices. So it's still popular in offices. And let us see an example of how Ethernet is used in offices. What you see in this figure is actually a setup. We want to access some services over which exist on the internet, and we are here. So you can see we have like the wired network, Ethernet switches, Ethernet routers, etc. And we have the wireless access points or Wi-Fi access points here. And again, we have the wired portion of the network. So you see, actually, normally we use the two technologies side by side in order to connect to the internet or to avail services on the internet. Okay. And another advantage of the Ethernet is that it is possible to scale your network both in terms of distance and also in data rates. So you can scale your network, you can add more PCs, you can add more segment to this setup. An enterprise can easily extend an Ethernet network among a number of buildings on the same campus or even at distance location with a high speed. Beside from home and offices, we also use Ethernet in data centers. We also use them in enterprises. We also use them in wide area networks. So let us see how they are used in enterprises. Okay. So as I just mentioned, an advantage of Ethernet is that you can actually extend your current setup. You actually could have more security control on over your enterprise network if you are using Ethernet. Okay, because wireless networks, they are more open to attackers as compared to the wired network. Similarly, you can use Ethernet in data centers, and this is the dominant standard which is used in data centers as well because of the high data rates that it supports. And you know that for data centers we actually require high data rates, and that is achievable with the help of Ethernet. And also you can scale up your data centers with the help of Ethernet. You can scale your data rates from 100 gigabit per second to, for example, to 400 gigabit per second, and so on. Beside from that, we also use Ethernet in wide area network, not only in local area network, not only in data centers, but you can also use them in a wide variety of other setups by using T1 lines, by using SDH technologies, by using ATM technologies, etc. You can use them for wide area network as well as for metropolitan area network as well. Some data rates, but these are outdated. I'm sure we have much more larger data rates available for Ethernets nowadays. Okay, like 400 Gbps, etc. Okay, let's turn our attention from Ethernet to Wi-Fi. I'm sure every one of you would be familiar with the word Wi-Fi. Okay, this is not something new for you. Actually, we use them in our homes, at our schools, our colleges, our universities, our offices, workplaces, restaurants, hotels, airports, blah blah blah. Wherever you go, you will find Wi-Fi networks over there. But let us see some technicality about the Wi-Fi network. We can classify wireless network at a high level into two categories. One type of wireless network, they depend on infrastructure, and the other type of wireless network, they actually do not depend on the infrastructure. Infrastructure could be anything like a base station, like an access point, like a tower, etc. It could be anything. And then beside from that, your wireless networks, they could be either single hop or they could be either multiple hop. So based on these two terminologies, there are going to be four categories: single hop infrastructure based, single hop infrastructure less, multi hop infrastructure based, and multi hop infrastructure less. Single hop, as the name indicates, all communication between a base station and a wireless host is over a single wireless hop. There is no intermediate nodes required for transmission of the data. An infrastructure based mean there must be a base station or something like that. Your 3G cellular network is an example of single hop infrastructure based network. Your 802.11 Wi-Fi networks, they are another example of single hop infrastructure based networks. On the other side, single hop and infrastructure less network require no base station, but still the communication is going to be single hop. An example of such type of network is the Bluetooth network or your Wi-Fi if you are using it in ad hoc mode. Similarly, we have multi-hop infrastructure based network, and the wireless sensor network is an example. Wireless mesh network is another example where the communication between source and destination will go through multiple hop, or you can say the message will travel to several nodes, intermediate nodes, before reaching towards the destination. There is a multiple hop, the concept of multi-hop or multiple hop and infrastructure based. Finally, multi-hop can be infrastructureless as well, and vehicular ad hoc network is an example of that, or flying area network, where the vehicles relay the message before transmitting it towards the destination, or the message will go through several nodes before reaching to the destination. Multi-hop, but we will not need any infrastructure, we will not need any base station, we will not relying on any access points, any tower, etc. Infrastructure less. Okay, so Wi-Fi is a predominant technology, and it is also standardized by the IEEE, and the standard here is 802.11. You see, in case of Ethernet, the standard was 3. Here the number is 11. And then you can put different letters like A, B, G, N, X, etc. in front of 11 to represent different standards or different substandards with different data rates, different performance, different ranges, and things like that. Like the Ethernet, Wi-Fi can be used in different areas. The first use is in home. And this is the predominant wireless internet access technology that is used in homes. It actually replaced the Ethernet cabling for connectivity. All the home computers can communicate with each other and with the internet with the help of Wi-Fi. There is no need for a physical cable now. And laptops can move easily from one room to another room, or even from outside the house you would be able to access your Wi-Fi network, or at least your neighbor would be able to access your Wi-Fi, and you would even not be know about that. So you need security mechanism to be on the safe side. Actually, the Wi-Fi provides a low-cost solution for accessing the internet. and you can connect your smartphones, your tablets, and even you can you can uh, you can set up the network that you can save the password in your smartphone, and there will be no need, the device will not ask you to connect to the network if you have do some setting. If you trust the network, if you tell your smartphone that it is my publicly trustable access network, so it will not bother you, it will not ask you for joining that network. Okay, beside from home, we can use public Wi-Fi, but that is very dangerous. Okay, be careful while you are accessing a public freely available Wi-Fi. Nothing is free. Hidden things would be there. And one of the example is hot spots. And they provided internet facilities at coffee shops, restaurants, stations, airport, BRT, hotels, hospitals, libraries, uncountable applications areas are there. Okay. We also have enterprise Wi-Fi like enterprise Ethernet. Many organizations, they actually set up their own Wi-Fi to allow access to their customers, to their employers, right? And also beside from enterprise, we have like retail, healthcare, hospitality. Wi-Fi is everywhere. So we have different application areas where Wi-Fi can be used. Well, there are some standards, but we will not go into the details. Beside from Wi-Fi, we have another type of network which are known as cellular, 4G and 5G. But before going into the details of 4G, 5G, it is important to understand uh, the generations of cellular networks. Actually, the cellular networks, they are the foundation of mobile wireless communication, and they support users in locations that are not easily served by wide network. Okay, so let us see some generations. Normally people start with the first generation when they talk about the cellular networks, but we are going to start from the zero generation. And zero cellular network generation, it is actually the predecessor of the first generation where everything was analog. Radio waves, communications, and technologies used for zero G generation was PTT, like push to talk, and MTS, mobile telephone service. AMTS was developed later on, but it was shifted from 0G to 1G. Okay, 0G networks doesn't provide mobility and roaming facilities. Okay, so the most dominant factor or important part of the history of cellular network is the 1G cellular networks, which were also analog in nature. They were used only for voice services. They support only voice services. There was no worldwide standard available for 1G cellular networks. The dominant countries that actually worked on 1G cellular networks were United States, Europe, and Japan. And the most successful standard of 1G cellular network was AMPS, which stands for Advanced Mobile Phone System, and also ETAX and JTAX for European and Japanese users. Actually, the AMPS was the dominant factor because it was developed by AT&T Bell Labs in 1970s or something like that in Chicago, and then commercially it was available on large scale. Beside from first generation, we have the second generation cellular network, and the focus of second generation cellular network was toward voice market, toward digitization. From analog, there was a shift towards the digital. In the second generation, the cellular phones were become digital. Okay, so shifting from analog to digital enables several improvements in terms of voice quality, in terms of security like encryption, and it also enables something which is known as SMS service. Okay, and beside from that, we have low data rate data applications available as well. Like you can now receive news, stock quotes, weather reports, and things like that. And the 2G technologies were divided into TDMA and CDMA based technologies, but we will not go into the details. Some people divide 2G into further subcategories like 2.5, 2.75G cellular networks, where they talk about the GSM technology, CDMA technologies, GPRS technologies, edge technologies, packet-based services, MMS, WAP, wireless access protocols, email messages, web browsing, things like that. All these things happen in 2G or 2.5 and 2.75G. But what dominated the 2G technology was internet access, and it was further enhanced in 3G cellular networks, which begins in early 1990s with the wireless broadband services. Now with 3G, you have the choice of CDMA. Remember, we have different types of access technology: FDMA, TDMA, CDMA, etc. So the choice of CDMA was available. Uh, Beside, 3G were more secure, increase in bandwidth, high data rates, fast internet access. IPTV concept arrived. Uh, Before 3G, the packages were too expensive, internet access packages, but with 3G the packages become become less expensive, and 3G phones appear to be available in the market as well. And some of the example of 3G based technologies were UMTS CDMA 2000, WCDMA, and things like that. Well, currently the dominant factor is 4G. In some countries 5G is in full fledged, but still 4G is the current standard, you can say, in our country. And it is primarily for data, not for voice is almost there. From the 2G we are working on voice communication. The focus is now on data, internet, right? Traffic over IP, quality of service, high data rates, high definition streaming is now available, live streaming. YouTube is there, high definition, high quality videos, highly secure internet services, although it's not secure, but still you can say highly secure. And some of the example of 4G technologies are LTE and LTE advanced, and also WiMAX and things like that. So 4G, and now we have the 5G, they are the foundation of mobile wireless communication. Actually, the fourth generation is, you can say, ultra broadband internet access, high definition mobile TV application, video conferencing, gaming services. You can play online game. Although I'm not in favor of playing games online, but still you have the option available. If you have the 4G connection available, then you can do things, amazing things. And finally, we have the 5G cellular networks, which is going to be the next generation, or I would say this generation cellular networks, because people start talking about something which is known as the sixth generation. Do you have any idea about sixth generation? If no, do and Google it. You will find some very interesting papers in which people start talking about sixth generation. What is going to be the next generation of cellular networks, right? Okay, so this was a little bit about cellular networks, and finally we will talk about cloud computing. Cloud computing is something which have revolutionized the current era of technologies. First, let me tell you what the cloud word is. Actually, each letter has a meaning. C stand for common, L stand for location independent, O stand for online, U stand for utility based, and D stand for availability on demand. Cloud computing is something which reflects these characteristics. You can say it is actually a model for enabling ubiquitous, which exists everywhere, on demand network access to a shared pool of resources. The resources could be anything, ranging from storage, from network, from server, from security, from application, or any other service. That could be rapidly provisioned, and that could be rapidly released with minimum management efforts. This is what cloud promise. In cloud computing, the services are delivered over the internet. and on demand from a remote location rather than residing on someone else's desktop or laptop or mobile device. Services are offered somewhere else. You are accessing those services by using the internet. By keeping this in view, cloud computing actually enables computing tasks and information to be available anywhere, anytime, from any device, as long as there is access to the internet. So cloud computing has several characteristics which are mentioned here. Broad network access, rapid elasticity, measured service, on-demand self-service, and resource pooling or polling. Well, there are other interesting things, you can say features or advantages of the cloud computing. So let us see them as well. I will mix up the thing, advantages and characteristics, so you have to give proper attention. The benefit of cloud computing is cost reduction. That is the main benefit of cloud computing, because the initial cost, uh, if you want to have your own data center, for example, or your own setup instead of using cloud services, then you will need infrastructure cost, IT equipment cost, software cost, networking cost, uh, manpower cost, construction cost, installation cost, maintenance cost, and things like that. But the cloud would save the initial upfront ownership cost, because the cost will reduce if you are using services on the cloud. And if you do not require to use the cloud services anymore, then you can release the services easily with minimum management efforts. That is the first advantage, reduction in cost. Similarly, the cloud services are scalable. If your uh, uh, if your organization demand for resources has increased, you can avail more services from the cloud based on your current demand. Hence, you can increase the scalability. And also, another important feature or characteristic of the cloud computing is availability. Cloud can increase the availability of the resources. Having access to software, platform, infrastructure from anywhere at any time, as long as you have the internet connection. Okay, so the availability is increased, and it is claimed by the cloud service provider that we are 99.99% of the time available for our customers. Okay, and also reliability is increased. Why cloud can increase the reliability of the system? And the reliability of the IT resource is an important factor for continuous business operation. Okay, one way to answer this question is that the modular structure and the redundancy in resources that are provided in the cloud, they actually increase reliability, and also the availability of the resources increase reliability. And also the system, if something goes wrong, the recovery time of the system after the failure is very less. Reliable systems are reliable, 99.99% of the time they are available, which means reliability. Beside from reliability, we have flexibility. You can avail any software, you can use any platform of your choice from the cloud. Customization, you can say, is another advantage. Everything is at your wish list. Which software you want to use, which storage technique or technology you want to use, which network bandwidth is required, which speed would you like to avail, and things like that. And maintenance is another important feature. Like, you do not need to worry about the security of your data, the storage of your data. You do not need to worry about the loss of your data. You do not need to worry about the software updates, the patches, the security, the monitoring, the health of the storage, the backups, planes, etc. Everything, they are the responsibility of the cloud provider. But the drawback of the cloud computing is security. Although we say that the cloud computing is secure, but still, that is the top concern of all the cloud customer and the primary concern for many users. because you lost control over the hardware. You have no control. Even on your own data, you do not have control where your data resides, where is your data stored, in which country it is stored, on which machines it is stored. You have no idea in most of the cases. So customers are not aware of where the hardware is. Okay, you have no feeling what it may be. It could be insecure, maybe there are chances. Okay, sometime the cloud service provider, they will, during signing the contract, they will tell you explicitly which security mechanisms they are using, where, in which country their servers are, where are their data centers, and things like that, how they protect your data. But still, security is a major concern, and the location of data is one of the major concern which is related with the security, right? Because the cloud service provider is responsible for storage and backup of the data. The service provider, although they deploy enough redundancy to guarantee the high degree of service availability and reliability. But in order to achieve this, the service provider has to choose locations that are geographically distributed. Maybe one data center is in Pakistan, but the second data center is in US. Some of your data is in Pakistan, but some of your data is in the US. If the data center is in your own country, you do not worry about your data, about the privacy of your data. But if it is in someone else or in geographically far away from your country, then you become worried about your data. Some countries require that business must store customer data within the country, but others allow it. Okay. And also another concern or drawback of the cloud computing is multi-tenancy environment. Search what is multi-tenancy. It is a unique deployment for each customer on a shared set of resources. Okay, you have a single hard drive, and on that you are actually storing the data of multiple customers. Cloud server providers, they offer virtual servers to customer by providing computing power using servers that host multiple clients, one server, multiple client, one hardware, one hard disk, multiple clients. Okay, even one machine, multiple users, virtual machines are there. Okay, so the concern is that because data belongs to different customer resides on the same physical server, there is a possibility that such data could be accessed intentionally or accidentally by other customers, because you are sharing your resources with other customers. Okay, and sometime more dangerously, some hackers could subscribe to a large amount of storage space where your data is on a virtual server, with the idea of accessing the data that remains in the storage area that is used by another customer. Okay, and trust is another factor. Trust requires the provider to have well-defined policies that follow known standards. For example, the cloud service provider should be able to provide the customer with a third-party certification for building trust of the customers, things like that. And last but not the least, internet should be there to access the cloud computing services. Coming back towards characteristic, I will go fastly. A broad network access mean capabilities are available over the network and access through standard mechanism that promote use of heterogeneous clients platforms. As I just mentioned, you can access from any device, from laptop, from mobile phone, from PDAs, from PCs, from workstations, and like this. Elasticity, we talked about it, that it will enable you to expand and sometimes reduce your resources based on your needs. And also MIAD services mean like utility based computing. The cloud, U stand for utility. Okay, you have to pay for the resources that actually you are using, and the resources would be available to you on demand. If you required a resource, then you can acquire it on demand. If you do not require, release the resource. And also the resources are shared multi-tenancy among different users. There is resource pooling. Here is a cloud computing platform. we have the internet, and here we have a data center, a cloud setup. You see many racks of servers, and they are interconnected with one another by using different switches, and we have a router which actually route the traffic to the internet. And here we have an enterprise, an organization, an office setup with different laptops, servers, and PCs connected here with the help of switches and routers. If you want to access data which is stored on a server somewhere in the cloud, then your traffic will route and goes through this internet. This is the request, and then the response will come from a server somewhere from the cloud. This is the basic setup. Okay. Okay, guys. So benefits, we already talked about it. What are the benefits of cloud computing, and also some disadvantages. Yes, we talked. Internet of Things. I would like you to elaborate these things. What is Internet of Things? Everybody is talking about it. What are the evolution of Internet of Things? What are the different layers of IoT, like the sensors or actuators which actually sense the environment, and all these sensors are connected with one another by using different standards, and they have the these devices has the capacity to handle a huge amount of data, communication, flow of data, sometimes storage of data, sometimes processing of data, sometimes making decision based on their data. All these things contribute to IoT, and data analytics is there as well. For large collection of devices, big data is generated, requiring a data analytic capability to process the data flows as well. So this is very interesting, Internet of Things, by the way. You have to explore more about Internet of Things. Okay, guys, you have to discuss this lecture in the physical class, which is going to be after a few days. Thank you so much for watching the video. Take care and goodbye.